Hello, everybody. I'm sorry I'm out today, but don't you worry. I'm still going to teach you this lesson anyways on how to draw a dot structure for an ionic compound. All right, you should have your handout in front of you. You should be taking notes along with this. I also have the completed notes that I'm about to go over posted on our Google Classroom. Okay, so basically what I'm going to teach you how to do today is how to draw the dot structure for an ionic compound. So that is a combination of a metal and a nonmetal. And just as a reminder, ionic compounds are formed via valence electron transfer. So the metal, an element with a low number of valence electrons, transfers its valence electrons to the nonmetal. The nonmetal gains it. Oppositely charged ions are produced. They attract each other, and the bond is formed. Okay, so what our dot structures are going to represent here is just one molecule in the lattice structure of an ionic compound. So remember, when you have a bunch of ionic molecules all together, they align themselves in this alternating pattern of positive and negative charges. They all attract each other strongly. So what we're going to draw today is just one molecule, one combination of positive and negative charge within that larger lattice structure. Okay, these aren't hard to do. So basically, what you would need to do is this. You would need to know the electron configurations for the elements that are bonding together. So just as a reminder, every time you see a capital letter, that means a new element is in a chemical formula. So if I was going to draw the dot structure for LiCl, which is actually called lithium chloride, here's how I would start. I would start by writing the symbol for lithium on my paper, which is Li. These are the old reference table boxes, but I left them there just to show you lithium's electron configuration is 2-1, so it has one valence electron. Chlorine is a separate element, so I'm going to write it separately, and it has 7 valence electrons. So I'm going to go ahead and give it 7 dots. So remember, these bonds are formed when the metal, which is lithium in this case, transfers or gives its valence electrons to the nonmetal, which is chlorine in this case. What you draw, the dot structure, is the result of that transfer. So what I just drew here is optional. It's up to you if you want to go through this, but this is how the dot structure comes to be. So once you've transferred your valence electrons from your metal to your nonmetal, you're going to draw the result. Lithium has now no valence electrons. It gave it to chlorine. So now it has no dots, brackets, because it's an ion. It lost an electron, and it lost 1 electron, so we would give it a +1 charge. Chlorine took on that electron. It's now an ion. It had 7 valence. Now it has 8, so 8 dots. It gained 1 more valence electron, so -1. So this is the correct dot structure for lithium chloride. A lithium ion with a +1 charge, no dots because it gave away its valence electron, and a chlorine ion next to it, attracting to it, with a -1 charge due to the gain of an additional valence electron. It had 7 valence electrons at the start, gained 1 more, now it has 8, thus 8 dots. So it's basically like the ion dot diagrams that we learned in our first unit being put together to form a compound. Okay. So the next couple of slides here are just basically what I just went through. When you go to draw an ionic dot structure, you write the symbol for the metal first, surround that symbol with the correct number of valence electrons, outermost electrons for that element. Do the same thing with the nonmetal, write the symbol, draw 1 dot for every valence electron in the nonmetal atom. And then remember, you always transfer in an ionic bond. They're formed via valence electron transfer. The valence electrons from the metal to the nonmetal, or from the element with a low number of valence to an element with a higher number of valence electrons. Once you do that transfer, you've gone from neutral atoms to now charged ions. So make sure you surround each element symbol with brackets and put the appropriate charges. In this case, it was a +1 and a -1 in your diagram. Okay, all that's left to do now is let's practice. So we're going to go a little bit further here. We're going to move away from just 2 elements combining, or 2 atoms, I should say, combining up to 3 or more. So how you know if more than 1 atom of an element is in a chemical formula is you see little numbers. Those are called subscripts. So like I don't see a number after Ca here. It implies there's just one calcium atom in this formula, but this 2 here after Cl tells me there's 2 chlorines for every 1 calcium. So what you're trying to represent again is a piece of the larger lattice structure. So all these ions, this 1 calcium and these 2 chlorines, they have to attract each other. So a trick so that your final result shows the ions all attracting towards one another, a trick is if you have more than one atom of an element, put the element you just have one atom of in the center of your diagram. So like I have 1 calcium here, and then I have 2 chlorines. So it doesn't matter where the chlorines go, like top, bottom, right, or left, but just notate 2 chlorines. I'll go left and right on either side of the central calcium. So again, the atom you just have one of, stick it in the middle, and then surround it with the atoms that you have more than one of. Okay, once you get all that set up, check out your valence electrons. Calcium has 2, so you give it 2 dots. Chlorine has 7, so each chlorine gets 7 dots. Okay, so once you have your valence electrons all hooked up with the atoms, it's time to transfer. Oops, I forgot a dot right here. Okay, so the calcium is going to give away its 2 valence electrons to be stable. Each chlorine just needs 1 more to achieve stability. Each chlorine has 7 out of the 8 valence electrons. So what calcium's going to do is it's going to split them up. It's going to give 1 valence electron here. It'll give another one here. So when I redraw this, okay, the diagram is the result of the transfer. What I would have is a central calcium ion, no dots, because it gave away its 2 valence electrons, plus 2 charge to show it lost 2 electrons. And then in this case, on either side, I'll have 2 chlorines, 8 dots apiece. They each gained 1 extra electron from calcium. So each chlorine is going to end up with 8 dots, 8 valence electrons in total, and a -1 charge. So something like that is a correct dot diagram for CaCl2. Basically, what you want is all your ions attracting each other. This negative ion attracts to that positive ion. This negative ion attracts to that positive ion. So you just want your charges to like alternate, have a negative next to a positive. All right, let's do the next one. So up next here, we have, oops, wrong way. Up next here, we're going to draw the dot structure for Li3N, which is actually called lithium nitride. So see the 3 after the lithium? I've got 3 lithiums here. No number after the nitrogen, which implies there's just 1 of it. So take the nitrogen, the element you just have 1 of, put it in the center. And then again, top, bottom, right, and left, pick 3 of the 4 sides, doesn't matter which 3, to orient your lithium. So I'll go bottom, right, and left, but it doesn't have to be that way. So once you get your lithiums all hooked up with your central nitrogen, figure out how many valence electrons the atoms start with. Lithium has 1, so each lithium gets 1 dot, 1 valence electron. Nitrogen has 5, so you give it 5 dots. And then it's time to transfer from the metal, the first element in the formula, to the non-metal, the second. Lithium is going to ditch its valence electron. It's a tiny atom, so it's stable with just 2 electrons total, 2 valence. Nitrogen, though, needs to gain 3 more to achieve the stable 8. So each lithium is going to give its valence electron to the nitrogen. And what you're going to end up with is a central nitrogen that's stable with now 8 valence electrons. It gained 3 in total from the 3 lithiums, so a -3 charge. Each of the lithiums gave up their 1 valence electron. So you're going to go ahead with a +1 on each of them. Okay, something like that is the correct dot structure for Li3N, which is actually in fact called lithium nitride. Okay, that is the idea. What you should do now is go find lab 14, the ionic bonds gizmo, work through that, and you should receive a partial key for the dot structures at the end just to make sure you're doing everything correctly. All right, have a nice weekend, everyone. I'll see you on Monday.